What's up? Is this working? Let's assume yes. Um, let's do the last homework. It's shorter, shouldn't take that long, but what it leads us to is like the last two things to then enable us to answer free response questions A, B, C, D, E. And that is your review. Your review is a bunch of free response questions where every single part like is covered, lessons 1 through 4. So call this a mini homework, but then think about your overall homework, which is like combining this with everything else we learned about motion and derivatives and antiderivatives and stuff like that. Anyways, it's two different things combined in one. Distance, which most people can get and understand, but like one easy shortcut to finding distance we discovered. And then something completely new, which is very tricky to understand, which is average, an average of something, okay? If we have looked at velocities, signs, which is the derivative position, over the course of the entire unit, and if we understand that the area under the velocity is the displacement, we should understand like displacement versus distance. The displacement is just like the combination of your individual displacements combined, where it's like I went to the right 5, I increased my position by 5, but then I decreased my position by 3. I ended up 2 away from where I started. So that's just like combining all of my velocities over my time interval A to B. And that's displacement. In this case, it's, if this is A and this is B, it's 2. So I ended up 2 to the right of where I started. It's the same as just finding the change in position. Whatever my position is at time B, I don't know what it is, but whatever it is, it's 2 to the right of where I started at A. Now distance, you guys know the distance can be found if I go to, we'll call that star. From A to star, if I keep that displacement, positive 5, and then if I have the negative displacement from star to B, I'm just going to subtract those negatives. Keep positive displacements positive, subtract negatives, and you'll get the answer 8. But what we understand is that if instead of doing this and doing all of this analysis, we could just using our calculator find the accumulation of my absolute value of my velocities. These are my speeds. This is speed times time. So why do you need an absolute value? You don't need it. You don't necessarily need it. But it ensures that you are accumulating speeds, or you're having your calculator do a bunch of calculations of speed times time. That's a T. Versus velocities, which could be positive or negative. So you don't need it, but it is like a shortcut if you have your calculator. If you don't have your calculator, you need to do your sign analysis. You need to understand when you're moving to the right, moving to the left. And you could use your position function actually to find your positions here, here, and here. And then if you find your 3 positions, you'll get your displacement. So whatever. Do you need an initial position to calculate displacement or distance? No. That's a very important distinction. A lot of people make a mistake on this. You don't need to incorporate like where you started. Let's say for this situation, I started at a position of 4. Okay? My position at star would be 9. My position at B would be 6. Again, my displacement is 2. My change in my position from 4 to 6, I ended up 2 to the right of where I started. But my distance is 8. I take that 4 to 9, that changes 5. Take that 9 to 6, that changes 3. Add those 2 changes up, you get 8. So don't like add 4 to 2 to get a displacement. The 4 plus the 2 is your future position. I didn't want to zoom in. Okay. So let's do some problems. You're given velocity, you're able to use your calculator. So, for every single one, just for these two, it's easy. 0 to 3 of v is the displacement. That's your change in your position. That's x of 3 minus x of 0. You don't know what x of 3 is or x of 0 is, but you know the change. And then 0 to 3 of absolute v is going to be your distance. That is not x of 3 minus x of 0. That just makes sure all of your velocities are positive. Here, 1 to 2 of v is my displacement. 1 to 2 of absolute v is my distance. Okay? And I'm just going to use my calculator to calculate those quickly. But then the next two, we need to be careful. So again, with a calculator, shortcut. Without a calculator, we'd have to do a little bit more work, which we'll do on the next page. Oh, little helpful hint here, guys. Find the distance first, and then you'll be able to subtract or delete the absolute value. So go over math, over to num abs. This will be the distance, t squared minus 3 sine t. 0 to 3. Notice how your calculator works hard to get that answer. It's because it's doing a lot of calculations in the background. Come back, delete the absolute value, and then you see that there obviously was some change in direction for my distance to be greater than my displacement. If you wanted to, look into it further, make sure you understand the motion and what's going on, you would graph. You go to the left, then you go to the right. You could find that value there. This negative displacement is how much we're going to the left. This negative area, this positive area is how much we're going to the right. Make both of those areas positive. Or if you wanted to, you could graph the absolute value so you could see how it's like, all right, here's my speed over the course of the times. But I'm not going to do that because it's extra work. If we have to do it, we'll do it. All right, back to the home screen. One to 2. Negative 3 e to the t plus 5t. Oh, I did the classic mistake. Do the distance first. See, when you insert an absolute value, you can't put it around the stuff. So do the distance first. Okay, 6.512. That's the distance. Oh, negative 6.512. So what's interesting about this is I can tell right now that my velocity between 1 and 2 is strictly negative. My derivative is strictly negative, which means my position's decreasing, and I decreased my position by 6.512. I ended up 6.512 to the left of where I started. Well, your calculator takes that into account when you use the absolute value, and you're like, well, you moved a total of 6.512, whatever distances. You have a calculator, but you're given position. What you need to do is look at the derivative. Look at not x, but x prime. Look at v. And again, since you have a calculator, it's like, boom, I'm done. You know, I can just type this in. V is the same as x prime. So type that in, that's the displacement. Type this in, this is the distance. If you wanted to, though, we could do a little bit of work. You'll find that your velocity, like we could set our velocity equal to 0. This is just me doing this without a calculator, and you get t as 1. So from 1 to 3, your signs are going to always be the same for your velocity, which is your derivative. If I plugged in 2, I get a positive. So what I'm going to find when I plug this in is that my displacement and my distance are going to be the same. And honestly, I could find it really quickly. If I just do my position at time 3 minus my position at time 1, that's going to be the same. And I'm going to just do that right now, just to show you. 27 minus 9 is 18. Minus negative 2 is 20. Both of these answers are going to be 20. Okay? This is me finding the area under my velocity just by finding the change in position. This is going to give me my displacement and my distance because my velocity is positive consistently. Let me just show you that, and this is like good for your understanding of like what exactly is going on. If I go to 1 to 3, math, num, abs, the derivative, 3t squared minus 3. I get 20. If I did the same thing without, I'm going to get 20. That would have been a good question to do without a calculator. Here, you give an acceleration, you're asked to find the displacement and the distance. You need a velocity function. You got to remember that the derivative of velocity is a, is acceleration, v prime is a. So if you have a and you want v so that you can plug stuff in to find your displacement and your distance, you're going to have to take the antiderivative of a. So understanding this is v prime, going to take the antiderivative. I get t squared minus t plus c. Now, a lot of times when we're finding areas, we don't have to worry about the c. That's only if you're subtracting things and the c's will go away. In this case, I need to find c. I need to figure out what the exact velocity function is so I can analyze it. Plug in 0, I get 3. So this is my velocity. No, it doesn't work. So I can't factor this, so I can't really do a good sign analysis of this. If I plugged in 2, I'd get 4 minus 2, which is 2 plus 3, which is 5. If I plugged in 4, I'm thinking that my velocity is going to be positive here as well. Since my velocity is positive, between 2 and 4, my position is going to be increasing. Now, here's the problem, though. I don't have a position function, but I could take the antiderivative, plug in 4, plug in 2, and subtract them, and I'll get this displacement. And that's when my c doesn't matter. If you subtract x of 4 minus x of 2, you'll get the area under your derivative without having to worry about finding c for this situation. Now, we have our calculator, so let's just make it easy on ourselves. 2 to 4 of v, 2 to 4 of absolute v. The answers are going to be the same. And let me just predict what it's going to be. X of t, which is the antiderivative of v, is 1/3 t cubed minus 1/2 t squared plus 3t. I don't want to plug in 4 and 2 to that, so like let's just skip that. Sometimes like using your calculator helps, sometimes it doesn't. In this case, it really helps. Finding the area under t squared minus t plus 3. Done easily with a calculator, more involved without. All right, I bet you if I use the absolute value, I'm going to get the same answer. I should have done that first. Classic mistake. Can't tell which way is faster. Yep. Okay, so here, my distance and my displacement are the same. All right, now we don't have a calculator. Great, perfect. 0 to 3. Since I don't have a calculator, I can't use an absolute value. Yes, in an ideal world, I could just like do that. But it's like, how do I get this without a calculator? You can't. You can't. You're going to have to do a full and sign analysis. Since this is a velocity, you're going to set your velocity equal to 0. Again, this is the derivative of your position. You're going to get 0 and 2. All right, cool. So here's my velocity, which is my derivative of my position. 0, 2, 3. My velocity is negative until 2 and positive from 2 to 3. So that means I go to the left and then I go to the right. Now if I want to find my displacement's easy. We could separate this, which we'll have to do, but not yet. We can just go and find 0. Actually, let's separate. We're going to have to do it anyways. Let's go ahead and figure out what the displacement is from 0 to 2 and 2 to 3. Now, how do we find that? How do we find the displacement from 0 to 2? The area under my derivative? Well, we got to find x of 2 minus x of 0. This is when we don't have to worry about a plus c. So let's just write it out. I got t squared minus 2t. The antiderivative gives me x of t. It's 1/3 t cubed minus t squared. Plus c, but I'm going to find x of 2 minus x of 0. X of 2 minus x of 0. The c's will go away when I subtract. This is 8/3 minus 4 minus 0. So 12/3 minus, so negative 4/3. Good, that's a negative value. That looks good to me. And now let's go from 2 to 3. I already know what my position at 2 is. At least that's my displacement. It's negative 4/3. So I just need to really find x of 3. X of 3 is 27 divided by 3, which is 9, minus 9, which is also 0. So I'm going to actually go back 4/3 as well. If we want to do that out, we can. 2 to 3 of t squared minus 2t. Again, I use 1/3 t cubed minus t squared plus c. That's my position function. From 2 to 3, I will get 0 minus negative 4/3. That's x of 3 minus x of 2. So what is my displacement? 0. That would actually have been easier to find if we just did 0 to 3 to start. But what is my distance? It's going to be 8/3. That negative turned into a positive, that positive staying as a positive. We have to use a position function to find the change in position. We don't know what the positions are. We don't know where we really start, but that doesn't matter. We know the change. We don't need the c when we're finding the change. We will need a c, or we will need something so we can find where we start and where we go. you're subtracting, you don't need the C. If you're asked to find a position, an actual position, you need the C, or you need to kind of incorporate this stuff. Let me just check for fun. If that's 8/3, then I'm done. Yeah. Now notice your calculator is a little bit off. That's because your calculator, again, does like a mathematical process where it's taking V's times T's, and it ends up approximating versus getting the actual sometimes. So there is a demonstration of it approximating. But there you see 0. Same thing here. 0 to 3. 3t minus 3. Set that equal to 0, we get 1. So that's my derivative, 1 from 0 to 3. It'll be negative and positive again, which means my position decreases then increases. Let's find the change in my position, or the area under my derivative. I'm going to go ahead and split it up since I don't have a calculator. I'm going to show you all the work like I did here, but if you guys want to just go and do x of t is 3/2 t squared minus 3t plus c, and then just know that the c's are going to cancel. X of 1 is 3/2 minus 3. X of 0 is 0 plus c. Knowing that when you subtract the 2, the c's will cancel. You'll just have 3/2 minus 3. That's 6/2, so that's negative 3/2. And then from 1 to 3, you get 27/2 minus 9. So that's 18/2, so that's 9/2. So that's a plus c. If I do minus 3/2, if I do 9/2, which is x of 3, kind of, minus negative 3/2 plus c. The c's will go away. I get 12/2, which is 6. I don't like doing that. I'm better kind of doing the traditional method, which is showing the work, find the area under 3t minus 3 from 0 to 1. I will take the antiderivative, plug in 1, plug in 0. 3/2 minus 3 minus 0, the c will cancel. That's negative 3/2. And then if I do from 1 to 3 of 3t minus 3, again, 3/2 t squared minus 3t plus c, but it's 1 to 3. This is 9 27/2 minus 9 plus c minus 3/2 minus 3. This is 18/2, so that's 9/2 minus, this is negative 3/2, so 9, 10, 11, 12/2, which is 6. So displacement is 6 plus 1.5, so 7.5, so 12, 13, 14. Sorry, that's distance. Displacement will be 6 minus 1.5, so 5.5. This will be 7.5. Let's double check. Again, we don't have to worry about the actual positions up here. What the position is 0, what the position is 1, what the position is at 3. These are the change in the positions. Okay, make sure you understand that. We don't have to incorporate an initial position or anything for displacements. 0 to 3 of 3t minus 3. We don't need c's when we find this third row. 4.5. Oh my goodness, 6 minus 1.5 is 4.5. Okay, I got it. But what if I have an absolute value is going to be. Hopefully we are thinking about what's going on rather than just doing it blindly. Like hopefully we really understand why this third row is the displacement, why we don't need the C in this instance versus like where did it go or when do we need it? We will need it to find actual positions. Like where do I start? Where do I go to? 7.5. Okay. 2 more questions, then we switch over to average. We got a velocity. What is the distance traveled by the object from 0 to the first time it stops? First times it stops is when the velocity is 0. That's when the derivative position is 0. I'm already given my velocity, so I need to figure out when this is 0. That's when cosine is going to be 0. Cosine 0 at pi over 2. So if you remember how to do this, you would divide everything by 3, and we get pi over 6, multiply everything by 1/3. Or you would figure out that pi over 6 times 3 gives us pi over 2, and cosine of pi over 2 is 0. Now, my velocity from 0 to the first time it stops is going to be consistent. I don't know if I gave you a calculator or not. Whatever, we'll find. From 0 to pi over 6, let's plug in something like pi over, I don't know, think about it. If I plug in 0, I'm going to get positive 2. So my velocity is going to be positive. If I plugged in anything in between, my velocity is going to be positive. The next 0 would be at like negative pi over 6. Yeah. Position's increasing. I need to just find my displacement, and it's going to be the same. Now to do that, I'll need my position. At pi over 6, my position is 0. Which means you have to take the antiderivative of this. Now the antiderivative of cosine is sine. Now to take the antiderivative of cosine 3t, I need to undo the 3 in here, the derivative. If you remember, this would be the antiderivative of 2 cos 3t. It'd be 2/3 sine 3t. So I need my position at pi over 6, which is 2/3 sine pi over 2, minus my position at time 0. I don't need to worry about the c because I'm subtracting. It'll go away when I subtract. 2/3 sine 0. I get my answer is 2/3. Okay? We can do that without a calculator. I guarantee you the distance and the displacement are the same because your velocity is positive. Boom. All right. Averages. Now things get a little bit tricky. I liked how I introduced it to you guys in the lessons. It started with, this. What does this mean? This is the rate of change of position over a time. This is the average rate of change of position. How does position change? Well, we talk about how that means it's the average velocity. But we also know that the change in position is your displacement, which could be found by finding the area under the derivative, or the area under your velocity. So you could find an average velocity by finding the change in position over change in time, or by finding the change in time, keeping it on the denominator, and then replacing this with an integral, which we can find using our calculator very easily. Now, why this gets confusing is I could do the same thing with position or acceleration or anything. Average position. Okay, well, if average velocity includes the area under velocity, the average position would be this. The area under position. How would you find the area under position without a calculator? You would actually need its antiderivative, big X. The average rate of change of big X would give you the average X. It's confusing. It's like an average derivative comes from an average rate of change of the original function. A lot of people have a tough time making this connection, which is why we usually kind of like not do this anymore. And instead, we just hold on to this understanding of average. The average of something is 1 over b minus a, integral from a to b of that something. Understanding that this can be found with a calculator quickly. Calculator can find the area quickly, but we can also find that by taking an antiderivative without a calculator. Okay, so let me just show you. I'm giving you the position. I'm asking for the average position. 1 over b minus a, integral from a to b, of what I'm trying to find the average of. If you have a calculator, boom, this is easy. This is done. We're good. So let's do it. I have a calculator. It's great. Okay, negative 2.25. If I did not have a calculator, I would have to take the antiderivative of this to give me big X. And I'd have to find the change in big X from 0 to 3, knowing that the plus c won't have to worry about it. Here, I'll show you. 3 to the 4th divided by 4, 3 cubed, 20.25 minus 27 divided by 3. Okay, because the position at 0 would be 0, or not position, big X of 0 would be 0 plus c. Now, average velocity, why don't we just start with 1 over b minus a, integral from a to b of what we're trying to find. Okay, average velocity would be this. But how do you find this? Well, with a calculator, you could use v. But we know that without a calculator, you could just do the antiderivative at 2 and 0. So I can plug in 2 into x. I get 8 minus 12 minus 0, which is negative 4. Negative 4 times a half is negative 2. You could find the same thing with a calculator. Finding the area under velocity, dividing that by 2. Boom. Okay? Calculator, no calculator. Sometimes, like, I don't know. You got to be ready to do both, and you can do both. Okay, no calculator. Average velocity. All right, 1 over b minus a, integral from a to b of what we're trying to find the average of. It's velocity. Okay. To find this without a calculator, we have to take the antiderivative. To get a position function, this is my position function. It's got a c. Okay. Honestly, right now, I don't care about the c. I do know that c is 2, but I won't care about it because I'm going to be subtracting. I'm going to find the change in position. Plug in 3, and I'll plug in 1. 27 minus 27 is 0. 1 minus 3 is negative 2. So my average velocity is 1. You can check that with your calculator. Now, you want the average position. Well, we need to start with our position function. You can't have the plus c anymore, okay? Because to find the average position, you're going to need the antiderivative of position. You're going to need big X. You're going to need the average rate of change of big X to find the average X. Just works out. Or maybe that doesn't make sense to you. To find the average of something, 1 over b minus a, integral from a to b of that something. Find the average X, boom. To find this without a calculator, you have to take the antiderivative. I know it's the position function. And it's like, why would I take an antiderivative of position? This is why. We can use big X or the antiderivative of like F to get big F. We can use big F to find an average F. It's one reason why. I'm sure there's other reasons, but that's all we have to care about in this class. So here is regular X. This is big X. 1/4 x to the fourth minus t cubed plus 2t plus c. Now again, we don't know what the c is for big X, but we don't have to, because when we subtract big X of 3 minus big X of 1, the c is going to go away. 3 to the fourth, 3, 9, 27, 81. 81 fourths minus 27 plus 6 minus a fourth minus 1 plus 2. I'm leaving it like that. If this is a free response question, I could leave it like that. That's fine. Let's just figure out what it is. 1/2 times, just make sure we did the calculations correctly. Your calculator needs the position function to find the area under position. Your calculator does positions times times. It does a numerical process. It does not use an antiderivative. So don't plug in the antiderivative. Nice. We as humans must take an antiderivative, must plug in the values and find the change in the antiderivative. This should be -2 after all said and done. I bet you I could have done this if I actually cared. I do care. This is going to be -2. Divide that by 2 is negative 1. 1/4. I could have subtracted 1/4 from 81 fourths and get 80 fourths, which is 20. 20. So 20 minus 27 plus 6 plus 1 minus 2. -7, -1, 0, -2. There you go. -1. Okay? So without a calculator, you might have to take the antiderivative of x to find the area under x to find the average x, which will be the average rate of change of big X. All right, these ones should be easy. Oh, this is good because they give you x of 0, 7. We should be experts at these. They're really easy. 0, 3, 5, 6. Positive, negative, positive. Positions increasing, decreasing, increasing. The area under my derivative is positive 5, negative 3, positive 1. My position at time 0 is 7. My position at time 3 is 12. My position at time 5 is 9. My position at time 6 is 10. Displacement. 2 ways to find it. Change in position. 3. 7 to 10 plus 3. Or 5 minus 3 plus 1. That is the area under your velocity from 0 to 6, which is equal to x of 6 minus x of 0. 3. 2 ways to do it. Distance. Well, you can make the velocity all positive. You could say my increase 5 minus my decrease 3 minus the negative 3 plus the 1, or just make all these things positive. 5, 6, 7, 8, 9. Distance is 9. Okay? What is the average v? Okay, well, the average v, 1 over b minus a, integral from a to b of what we're trying to find the average of. All right, we can either call this the area under v. Okay, here's the area under v. Or we could say, oh, that's the change in x. Okay, there's the change in x. All signs point to 3. Don't forget to multiply by 1/6. The average velocity overall is 1/2. Okay, cool. I'm just gonna show everything. I gave you x of 4 is 72. Fantastic. I thought I was like showing you that you don't need it, so it's not used, but like I'm gonna just really drive home our full analysis of things. So hopefully you're understanding how there's multiple ways to get the same answer, which is why this unit is complicated. We don't like having multiple ways to do the same thing because we're never sure what way is best. You know, it's whatever you want. Okay, x of 4 is 72. I know x of 3 has to be 75. I'm going to subtract that negative 3, or I'm going to add the 3. I'm going to subtract the 6. X of 1 is going to be 69. And I'm going to add the 2 to get 71. 71 minus 2 plus 6 minus 3. Great. What is the displacement? Well, 1. There's one way to find 1. Or this plus this plus this. 1. You don't need this. You didn't need it. You could have just added these. From 0 to 4 of v is 1. Yes, it is x of 4 minus x of 0. It's 1. Distance, well, you go down 2, up 3, down 3. Well, it's like you went 2, you went 6, you went 3. Make all of these positive, you get 11. What's the average velocity? 1 over b minus a, integral from a to b of what we're trying to find the average of. That. I don't need anything crazy. I don't need the antiderivative. I have it though. I have x of 6. It shouldn't have been 0 to 6. It should be 0 to 4. Whoops. The displacement, 0 to 4. I don't need this position. I might not have given it to you, and you still should have been fine. If you weren't given this, well, then you just wouldn't have that. And that's fine. You'd still find your displacement and distance that way. You just don't know your positions. But we now know like everything. And we are done with this unit. Okay? Review day, next class, all encompassing free response questions like you'd see on your test. Here's a free response question, part A, B, C, D. You're going to have to talk about your speed. When are things changing directions? When are you moving to the left? When is your position a max or a min? What is your displacement? What's your distance? What's your average position? What's your average velocity? All of that good stuff. Okay? Be ready to go. Mr. Messer out.